All right, so good morning, everybody. I haven't seen you in a couple days because we had the late start yesterday. So basically, all I have on the agenda for today is to go ahead and finish up the notes that we started on Wednesday when I saw you after the break. So we're talking about nth root radicals. Okay, it looked like this, and I do have extra copies in case anybody needs one. Anybody need a copy? Okay, cool. And I actually don't think we're too far away from the end. I think we were already on the second page, right? Yeah. All right, let me go ahead and get my stuff here. All right, so just a quick refresher. We're not only looking to simplify square roots, but we also want to simplify cube roots, fourth roots. So we have these warm-up values here. These are perfect squares, perfect cubes, and perfect fourths. Okay. As we scroll on down here, we have the different terminology and vocabulary used for our radicals. So whatever we're simplifying inside, that is the radicand. Now the number in the top left corner, that is what's really super important. That's your index. That's the root. That's what's going to be guiding how you're going to simplify these problems. And then the one thing that we talked about on Wednesday, when you have an even root, you're going to have two solutions, a positive and a negative. But if it's an odd root, like a cube root, you're only going to have one. Okay, and it's going to be the same sign as your radicand. The only time that you're going to get an imaginary answer is if it's an even root where the radicand is negative. There we go. And then we started looking at some expressions here. Okay, so we looked at perfect roots, and then we were simplifying non-perfect roots. Okay. So let me go ahead and give you another one just to kind of set the stage here. Let's say, yes. Yeah, absolutely. Anybody else need one? Cool. So before we go ahead and dive back into these, let's start with a square root because currently we're on the cube roots. So if I were to give you something like the square root of 32, 32 is definitely not a perfect square. If I take the square root in the calculator, it's going to give me a decimal answer. And that's okay because, I mean, they have a point. You know you missed it. Exactly. Okay, so what we're doing here is we're thinking about the largest perfect square that's going to evenly, and that's the key word, divide 32. So because the radicand here is 32 and my index is 2, we're looking at this top row. 16 would be the largest. Okay, so I could go ahead and rewrite this as the square root of 16 times 2, and then I go ahead and simplify what I can. We know the square root of 16 is 4, but 2 would have to stay inside as the new radicand. Okay. Now, I also want to go ahead and show something that we mentioned the other day, but I didn't go ahead and show. Let's say you run into a situation where you find a perfect square that'll divide it, but it's not the largest one. Okay, or perfect cube, perfect fourth, whatever number it is. Like, for example, 32 is divisible by 4, right? Okay, so let's say we broke 32 into 4 times 8. Okay, we're still going to get the same answer. It might just take an additional step or two. So I'm going to take the square root of 4, so that's 2, and we have the square root of 8 left inside. So now let's take a look at 8. What's the largest perfect square that'll evenly divide it? Okay, 4. So what if I went ahead and said, okay, we got the 2 right here. I'm going to rewrite 8 as 4 times 2. Now, I can take the square root of 4. I'm going to pull out a 2. But what do I do with the 2 that's already there? We're going to multiply. So the 2 times 2 gives me 4, and I still have root 2 left inside. So even if you don't choose the perfect root, you can still always get to the final answer. Okay, so there's nothing wrong with that. All right, well, that's a square. So let's look at number 4. Okay, and right now we're looking at because it's a cube, we're looking at this row right here. So that 3 on the outside, we're not going to worry about it right now until we actually pull something out. So 108. I'm looking for the largest perfect cube that will evenly divide that. Okay. It is 27. 27 times what? Okay. 27 times what? 4, yes. Once you identify that perfect root, everything else is going to fall into place. So I've got 3, so I'm going to rewrite this as, instead of the cube root of 108, I'm going to say 27 times 4. Okay. See, now I'm able to take the square root of 27. What is that? 3. So 3 times the 3 that's already out there, so I'm going to have 9 times the cube root of 4. And this is just something that I got in the habit of doing. If I have a root that's a cube root, fourth root, not a square root, when I simplify, I got in the habit of putting those in parentheses just so I accidentally don't believe that that radicand, or I said radicand, that index right there is a coefficient. No, wouldn't multiply. So yeah, if I had something like 9 times 3 square root of 4, that is something completely different than 9 cube root of 4. So that's why I have the parentheses there, just to kind of, show me that that's what we're talking about. Yes, yes, yes. Mm-hmm. That's it. Okay. So let's try number 5. And if you have any questions, definitely let me know. Okay. So this is the cube root of a negative 250. Now, good question. The radicand is negative. Will this go imaginary? It's odd. There we go. Okay. Will not be imaginary. Now this one, we'll know for certain if it's odd, well then your answer is always the same sign as your radicand. Yes, so if, yes, for the evens, we'll put the plus minus in front, absolutely. Mm-hmm. Okay, so only if it's an even with a negative radicand is it going to go imaginary, so odds are okay. But I see students, make that mistake all the time. They see we're taking the root of a negative, they'll put I. Okay. All right, so the thing here is the 250. So think about all of these perfect cubes right here. What's the largest one that'll evenly divide 250? 125 times what? Times 2. Okay, so I'm going to say the cube root of and I'm going to keep the negative on the perfect cube, negative 125 times 2. Okay. Well, the cube root of 125 is 5, because 5 times 5 times 5. What's the cube root of a negative 125? Negative 5, yeah. So it'd be negative 5 times the cube root of 2. Okay. Now, I'm willing to go ahead and skip ahead to a later problem unless anybody wants to take a look at number 6. Yes, yes. Yeah, you guys still got to fill out the pass. And do you have your badge as well? Okay. All right, so let's skip to number 7. So what's different about number 7 than what we were just doing? So it's a fourth root. Okay, so we're no longer looking at these middle numbers here. Okay, let me go ahead and erase that. So now, in fact, I'll go ahead and highlight it. Okay, so for number 7 and 8, we're looking at all of these numbers right here. These are perfect fourths. Okay, so the fourth root of 1 is 1. The fourth root of 16 is 2. The fourth root of 81 is 3, and it just goes in order, right? Okay. All right, so what we're looking for here, number 7, we have 3 times the fourth root of 162. Okay, so 81. In fact, 81 times what? 81 times 2. Perfect. That's the biggest part of these types of problems. If you can find that factor, the rest is just going to fall into place. Yeah, it's just a different root. Okay, so I've got 3 times the 4th root, but instead of 162, I'm going to say 81 times 2. Okay, let's see here. What was the 4th root of 81? Now, the square root of 81 is 9, yes, but the 4th root would be 3, because 3 times 3 times 3 times 3 would give me 81. So for this one, I'll go ahead and write it out. So we've already got this 3 that's on the outside. The 4th root of 81 is 3. There we go. So my final answer should be 9 times the 4th root of 2. And there we go. Same idea we've looked at previously. We're just looking at larger roots. So go ahead, try number 8. And then we're on our last section. So 5 times the 4th root of 2592. I'm sorry? Go up? Yeah. Oh, to see those roots? Yeah. So that 2592, that's a big number, but one of these, okay, don't say it out loud just yet, one of those will evenly divide it. Yeah. We're out of here, 55? Okay. Okay, so let's see. Perfect. Perfect. Okay. Perfect. Okay. All right. Or maybe instead of perfect, I should go radical. Anybody else want me to check their answer? Perfect. Nope. Okay. All right. So let me come on down here real quick. So you should be getting 30 times the 4th root of 2. Is that what you got? Nice. 30 times the 4th root of 2. Now, how we get that? That 5 in the front stays the same for just a moment. So the 4th root of 2592, okay, 1296, that's a 9 right there, times 2. So the 4th root of 1296 is 6. So when I go ahead and pull that 6 out, that's where I get my 30. So then we have the 2 left inside. How many people got that right? Okay, good, good, good. Are there any questions? Yeah. Where'd you get the 36 from? Oh, that's a square root. Remember, it is possible for a number to be different types of roots. Like we just saw one a second ago, like 81, that's a perfect square, but it's also a perfect 4th. So 1296 is actually, yeah, same thing. Okay, nice, 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 nice. All right, our last section. Okay, so now we're going to go ahead and include variables. But even though you're throwing variables in there, this is still really easy. You just got to remember one thing. But let's fill in these blanks. Square roots, the exponents must be multiples of 2. Cube roots, the exponents must be multiples of 3. And fourth roots, the exponents must be multiples of, what do you think? 4. There you go. That's exactly right. Now, as far as the numbers go, the 32, the 324, exactly what we were just doing. You're going to look for the perfect root that's going to divide it. You're still going to simplify it. But when it comes to the variables, you're going to take its power and you're going to divide it by the index. Okay. That's the key. Now, sometimes it's going to divide evenly, and you're going to be good to go. If it doesn't divide evenly, though, then your remainder will stay inside the radicand. I'll say radical. Now, let me show you what I mean. Okay, so we want to go ahead in number 9 and simplify 32, x to the 4th, y to the 9th. Okay, so the 32, we're going to go ahead and simplify that just like we did before. In fact, it was one of the examples that I used a moment ago. Okay, so square root of 32, let's rewrite that. What was the largest perfect square again? I forget. It was 16 times 2, right? So I know that the square root of 32 is 4, and then the square root of 2. But why do you think I left a little bit of room in between those? Because I got to simplify the variables as well. Now, here's the thing. I'm always going to take the power on the variable, and I'm going to divide it by the index. In this case, the index is 2. So what's 4 divided by 2? 2. So I can pull out an x squared. See, I took its power, and I divided it by the index. Now, when it comes to the 9, if I take 9 divided by 2, it's not going to evenly divide with it. It's not going to evenly divide it. There we go. Can't talk today. So we're going to do this. How many times is 9 divisible by 2? Okay, 4. Now, the number of times it's divisible, that's what you're pulling out. So I'm going to pull out y to the 4th, but what's the remainder? 1. So the remainder is what's got to stay as a power inside the radical. So because this came from y, it would be y to the 1st. And there you go. That's the answer. So you take the power and divide it by the index. If there's a remainder, that remainder stays inside. That's all there is to it. Okay. All right. Well, let's go ahead and try this next one. Now, 324, that actually is a perfect square. It's 18. Okay, so we don't have to sit here. Ooh, that's not what I wanted. Okay. So the square root of 324, that is 18. Okay, so I'm not going to have to worry about that. Now, my index is 2. Okay. So I'm going to go ahead and get the radical ready over here. So the first thing I need is to take 3 divided by 2. Always take the power and divide it by your index. Well, 3 divided by 2 is 1, so that means I can pull out a to the 1st. So what's the remainder? It's 1. So that means that remainder has to stay inside. Okay. For b, its power is 7, so I'm going to take 7 divided by the index. Well, 7 divided by 2, how many times? 3. So because that's 3, I can pull out a b cubed, but there's a remainder of 1, so that power has to stay inside. That's it. In fact, it might even almost be easier dealing with the variables than it was what we were just doing a moment ago. That's it. That's your answer. And then I'll go ahead and put parentheses around that. Choo, choo, choo. Okay, questions. Okay, well, let's try another one. Now, for number 11, you'll notice what's happening. Going to a cube root. So we're going to be dividing by 3. Okay. This one actually is really super nice to us. Now, 216 is a perfect cube. What is that? 6. So the cube root of 216 is 6. because 6 times 6 times 6. Oh, I scared myself. 666. Oh, there we go. See, for the m, 3 divided by 3, there's 1, no remainder. So there's no m that has to stay inside. It divided evenly. For the n, 6 divided by 3, that would be 2. Again, it divided evenly, so there's no radical. That's just the answer. Yeah. Yes. Oh, actually, normally we don't have to. Like, if I were to go ahead and give you a variable like x, it's understood that that power is 1. But when I first introduce this to students, I like to go ahead and put that there so they see where the value is coming from. But like, if you feel confident, yeah, we don't have to do that. Okay. Yes. Mm-hmm. So you don't have to put the 1 on there. That's it. Mm-hmm. Okay. Are we ready for one on our own? Okay. So try number 12. So I want the cube root of 56. R to the 8th, S to the 4th. Okay. So because you're dividing by 3, you're going to have some remainder, so there is going to be a cube root left over. And this one actually has several terms, so I'll just write it out in just a second because I know I'm going to forget if I walk around. There's just one detail that's off. That's the 8 right there. Remember, because you had to pull it out. So that everything's great. Besides that, this perfect. There we go. Let's see. Perfect. Yeah. That's exactly right. I know. This morning I woke up. I couldn't do anything with my hair. Did I ever tell you folks the story that back in high school I actually had really long hair, and one of the principals prior to graduation, it was at our rehearsal, uh, told me that if I didn't get a haircut before graduation, he'd see to it I didn't walk across the stage. Did I tell you all about that? Okay. You don't believe it? Why? I trimmed it. So I cut off like not even a half inch. I mean, it was still long. But he just said cut. I mean, he didn't say how short. So. All right. So let me go ahead and catch up with you folks. So we're not looking at the variables just yet. The cube root of 56, the largest perfect cube, would be 8. Okay, 8 times 7. So the cube root of 8 is 2. Now I'm going to go ahead and give myself a little bit of room. Here's the cube root. Okay. So the 7 is going to have to stay inside. All right, let's divide. How many r's can I pull out? 2. So remember, it's the power divided by the index. So 8 divided by 3, that's 2 with a remainder of 2. Okay. What about the s to the 4th? How many s's can I pull out? Just s to the 1st. So this time I'll just leave it as s. So what's going to be left inside? So it should be 2r squared s times the cube root of 7r squared s. Okay. How many people got that? Nice. Okay. What are we thinking? We having any trouble? Think we're good? Okay. I'm actually at the point where if you feel you want to do another one, we can go ahead and do another one, or we can use these as a review on Monday, or would you like to go ahead and just stop? Okay. What about if there's that one person who wants to do another problem? Don't let peer pressure affect you. That could be the greatest SEL of all. Math knowledge. His pencil's already up. Okay. All right, we'll stop there. See, I told you we'd have time today.